Hello students, this is our second day of the flipped classroom in our prerequisite chapter. The objective for this lesson is to remind you how to graph points, find distances, whether they be on a number line or on the coordinate plane, find midpoints on a number line or on the coordinate plane, and write standard form equations for circles. So we're going to first start out with just finding the distance between 2 points on a number line. So let's say, for example, that we have a number line and we have point A is at -3 and point B is at 8. The distance between A and B is just found by subtracting the point values and then find the absolute value of that. So for this one, we would say -3 minus 8 absolute value would give us the absolute value of 11, and our distance would be equal to 11. It doesn't matter about the order whenever you find distance. If you did the absolute value of B minus A, you would get the same result. That would be 8 minus -3, and that would end up giving you the absolute value of 11, which would be 11. So the answers match. On our next problem with the example, we have two coordinate points given to us, and we'd like to find the distance between the points, the slope between the points, the midpoint between the 2 points, and an equation line that passes through in point-slope form. So what we're first going to do is we're going to plot our points. So we have the point A is 3, -2, and you should always label the point with the capital letter and the coordinate. And we have the other point is at -1, 1. Okay, so we've plotted the points. Now to find the distance, we could either use the distance formula, which is a pain to remember, which is the following. And you should remember this from an Algebra 1 or Algebra 2 class. And this basically is a form of Pythagorean theorem. And that's all it really is. But it's very difficult for kids to remember that. What I generally tell people to do is when you have 2 points on a coordinate system, you just draw a vertical line through one point, a horizontal line through the other point, and you end up making a right triangle out of it. And now you can use Pythagorean theorem on the coordinate plane. You would subtract the y values, so you'd subtract y is 1, and you'd subtract 2, so you'd end up getting a value of 3 for this side. You would subtract the x coordinates to get the horizontal side, and that would equal 4, and that would give you the distance, which when you do the distance using Pythagorean theorem, it would be distance squared, the longest side, is equal to the shorter side squared plus the other leg side squared, which is 4, and we end up getting a distance of 5. So once you do it the way I'm showing using Pythagorean theorem on the coordinate plane, you can also get the slope really easy, because you know the rise amount over the run amount. So remember, slope is the rise over the run, and because the function from one point to the other point is going down, you know that the rise is going to be -3, and the run going from left to right is 4. The slope of this line would equal -3 over 4. But if you want to use the equation like you learned in algebra class, the equation is y2 minus y1 over x2 minus x1. The only problem with this equation is people generally will mistake the y values going on top for the x values, or they'll mess up the order in which they subtract them. To find the midpoint, which is the next part, all you need to do is to average the coordinates. So remember, we want to find about where the average of these coordinates are. So it's just an averaging process. So the average between, because remember the b coordinate is -1, 1, and the a coordinate is 3, -2. What's the average between -1 and 3? That's equal to 2. What's the average between, for the y coordinate, what's the average between 1 and -2? So typically to find an average, you add the numbers. So you'll say +1 plus negative 2. And you divide by 2. And that would give you, let me just clean up my space here. That would give you negative 1/2. So you can see here that the midpoint is going to be at 2 comma negative 1/2, and that's the average value of the coordinates for those 2 points. The last part of the problem is, can you find the equation line that passes through the 2 points and put it in point slope form? So in order to do this, you would need to write out your equation in point slope form. Y minus y1 equals the slope times x minus x1. This is called point slope form. You take any one of your 2 points. I'm going to choose point B. And I'm going to plug in the x value and the y value and the slope that I found from earlier. So I have y minus the b value for y is 1 equals negative 3 over 4 times x minus x1, which is negative 1. And that's going to result in the equation y minus 1 equals negative 3/4 x plus 1. And that would be my equation line in point slope form. Last example problem for the lesson. Do you know the standard form equation of a circle? And I spelt circle wrong, so I'm going to pause the video and fix that. And be back in a second. Okay, so we're back, and the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. The circle, wherever it's located, has a coordinate for its center, and the center is always at the h value, so comma the k value, and the radius would be the value to the outside edge of the circle. So if you look at this equation here, remember that it's minus h and minus k. So in the first part, we know that the h value, or of the x value for the center, is at 3, but notice this is a plus, so the y value, or the k value for the coordinate, would be negative 4. So we'd plot this, we'd go to 3, negative 4, 1, 2, 3, negative 4, and then we would have a circle of not radius 25, but a radius of 5. So then we would draw our circle. Radius of 5 would go up here. I'd go 5 to the left, 5 to the right, and then I have at least like something to help me get the circle. Or using my computer, I can just use a circle template, which is kind of like, I guess it's cheating. But that would generally be where the equation of the circle would be. Now I have a question for you to do, and I'm going to tell you that the center of the circle is at that coordinate location. So I'd like you to find the center and then figure out the radius of the circle and then come up with the equation and then check back with me in a minute or so after you unpause the video to see what the answer would be. Okay, class, well, we're back, and the answer is shown below. Hopefully you match with that. If you don't match with that, here's some things to consider. Did you find the right center point to be negative 4, 2? Did you find the radius by looking at both the horizontal and vertical distance from the center of the circle to its edge? If you found those things correctly, then you should have been able to find what the h value and the k value was, and remember to square the radius. I hope this video has helped, and tomorrow we'll do some more practice in class.